God has passed the baton to Nichole Price, a senior research scientist in benthic marine ecology, Bigelow Laboratory for Ocean Sciences. Nichole, okay, so I just want to say, I have actually read all of these multiple times, but I really am bad at pronunciation, so my apologies to everybody who's I'm messing up. But all right, Nichole received her BA in biology and math at Connecticut College and went to the University of California, Santa Barbara for graduate work, studying species interactions between tropical reef-building corals and microalgae. While earning her PhD in coral reef marine ecology, Nichole concurrently pursued an applied master's degree in applied statistics and probability at UCSB. For several years, she was an institutional postdoctoral scholar and eventually project scientist at the Scripps Institute of Oceanography, where she studied species biological response to ocean acidification, biogeochemistry, and natural variability of carbonate chemistry in shallow coastal regions. She moved to Maine in 2014 because she saw a unique opportunity to expand her research program to include interests about sustainable aquaculture in the face of future global change. Nichole's current research interests involve acclimation of marine species to variable carbon dioxide biological feedbacks, to boundary layer chemistry and ecosystem function in various oceanic environments, including temperate and tropical regions. Nichole's research is highly interdisciplinary and incorporates laboratory, field, and theoretical studies, mostly in collaboration with biogeochemical, physical oceanographic, and mathematical modeling colleagues. A long-term objective is to assess the ability of ecosystems to be resilient to perturbations and maintain function to provide the services that we rely upon into the future. Please welcome Nichole.
Well, thank you for that introduction, and thanks for inviting me to speak today. I'm very excited to be here. We know that the Earth's surface, the oceans cover 70% of the Earth's surface. What you might not realize is 3/4 of the Earth's cities are located along the seashore. So we are heavily reliant upon ocean resources as a human population. About 540 million of the people rely on industry from marine products and seafood for their primary source of food production. In Maine, we've seen changes happen over the past several decades in a place where we are also heavily reliant upon our seafood resources. We've seen fisheries collapse and some fisheries go down to record low levels. As an example, the lobster fishery, which used to be, the lobster used to be considered a cockroach of the ocean because it was so abundant. It would wash up in piles 2 feet high after storms. It was that abundant, and now it's a very important fishery and a growing fishery for our state, but it's a dangerous one because it's susceptible to some of the changes that our oceans are experiencing. Some of those changes are really visible, like the amount of plastic that is currently floating around the Pacific Ocean. It's created what's called the giant garbage patch. This is this area that's got a higher density of plastics in the ocean, several miles across. These plastics take hundreds of years to degrade in the ocean water and can kill millions of seabirds, hundreds of thousands of mammals, and countless fish on an annual basis. Those are the plastics you can see. There are also the microplastics that are in there that cause irreversible damage. We are overfishing our oceans. At least 32% of the current fisheries we have are overexploited to the point where they will not be sustainable going into the future. We also have other pollution problems that largely come from runoff from the land. 80% of the pollution in our ocean actually comes from runoff. That includes topsoil, the pesticides we were just hearing about, other additional nutrients from fertilizers and farming. There's also harmful microbes that can enter the ocean, and heavy metals that get washed off and enter into our environment. These can all impact the quality of the seafood that we have going into the future. Those are the visible problems. Those can be addressed in ways that we know. We can reduce, reuse, recycle. We can be mindful of the products that we purchase, so the seafood products sustainably harvested. Are we trying to purchase organic where we can? Are the cosmetics we use free of those microplastics? But there are invisible changes happening to the ocean that are harder to address and happening on a global scale, such as warming, sea level rise, and ocean acidification. This is a quick video of an extreme example of what can happen to our shelled organisms in acidified seawater. So this is a sand dollar that's been shot over time lapse that's dissolving in seawater with very low pH. This is what's happening as a result of ocean acidification. Our oceans have absorbed 40% of the carbon dioxide that we've put into the atmosphere since the pre-industrial period. That absorption has caused a series of chemical changes that are understood into the oceans and has changed the acidity of the water and raised the acidity by 30% over that same time period. So what can we do about these problems besides appealing to your government to help curb carbon emissions? Well, that's what Bigelow Lab for Ocean Sciences is starting to do, and that I'm starting to do as the director of the Center for Venture Research on Seafood Security there. We're trying to do matchmaking between policymakers, scientists, and industry members to really search for solutions and bridge that gap between knowledge and action. One way to do that is translate the most cutting-edge science, and that's what I'm hoping to do today, very briefly. We know that forests are important to protect and trees are important to plants because plants can absorb carbon dioxide during photosynthesis. But were you aware that our oceans also have forests that cover 9% of the seafloor? These are kelp forests. And these kelp are giant brown macroalgae. They're really cool because not only do they provide this environmental service, but they're also edible. And they're being grown right now in the state of Maine. This is the first place where we started farming in the U.S., and it's spread to about 7 states by now across the U.S. These edible kelp can absorb up to 53 billion tons of carbon dioxide out of the seawater per year, and can provide up to 440 pounds of protein per year per person when our human population reaches 10 billion people.
Yeah! So as an aside, we gleefully stole this event from Cambridge, where they call it Big Ideas for Busy People, which I didn't find very inspiring. It's a great event. Maine is so much nicer because you guys, your first question is, could you finish that, please? In Cambridge, they were like, how about this? They dive right in. So it's just another great example of how wonderful Maine is. So, yes, sir.
Do you have ever eaten kelp and what does it taste like?
I have. I'm just going to click it forward here.
Yeah.
I have eaten kelp straight out of the water. It has a lot of the umami flavor that has only kind of recently been described amongst chefs as another flavor palette that you have on your tongue. You can eat kelp in seaweed salad or wrapped around sushi. That's a dried form of a kind of kelp. There's a local place, Marshall Wharf Brewery. They put kelp in their beer, and I think it helps as a binding agent also, but it's pretty high in alcohol content, so beware.
I'm in on that one.
It's good.
And I would like to know sugar, kelp, and mussels.
Yes, that's where my research is really going next. It's finding a way to do multi-trophic aquaculture, meaning several different types of organisms cultured together, because there's a positive feedback that happens. There's detritus, or dead pieces of kelp that will fall off of the kelp farm. The mussels love to suck that up. At the same time, the kelp is sucking CO2 out of the water column, making it easier for those mussels to grow their shells, and decreasing the time to market size. So it's a doubly profitable situation to try to grow these together. There's a couple of other species pairings that are good examples of how it would work.
What's the downside of kelp? There's always a downside.
That's a good question. We're still kind of hunting around. You have to be wary of it. Shading, maybe, if you grow a lot of kelp really densely in an area where it doesn't grow that densely naturally, it can have a little bit of an impact on the seafloor below it, I would imagine. There's very little bycatch that happens when you pull in the kelp, because the point is to get it out of the water before it starts getting fouled and gumped up with other organisms. So any food has potential to become contaminated. And if you eat seaweed salad, for instance, that kelp hasn't been processed all that much, so there's a potential for microbes to be carried along with it into your body. And we don't know how much heavy metals the seaweeds absorb, but there's a lot of active research right now trying to figure that out.
What's the impact of companies like the one in Rockland, the name of which I forget right now, that their whole business is based in harvesting seaweed around the world? Isn't that kind of like removing their lungs?
So there's two different types of seaweed harvests that happen in Maine. There's the farming, where you put out lines with pre-seeded line and pull that in. There's also the harvest, where you're pulling up rockweed from the shores. And there's a lot of debate right now as to whether the rules we've set about rockweed harvest are appropriate to protect the rockweed itself from being able to regrow and protect the bycatch that does come in with the rockweed harvest. And that's a pretty active debate. There are sources that say there's no impact, and then other sources that say there's a pretty important impact. I will hedge my bet for right now. I haven't studied the rockweed myself directly. I'm right on the sugar kelp right now. But I do plan to look at it. I would like to know how much CO2 it absorbs and whether there's a potential that harvesting it actually stimulates growth and could lead to greater CO2 absorption than otherwise.
Besides reduce, reuse, recycle, and anti-chemical health, were there any other things you were going to mention about?
Yeah, it's a tough one. So, you can curb your own CO2 emissions by driving fuel-efficient vehicles. And if you were like me and got suckered into buying one of those VWs that was supposed to be fuel-efficient and then discovered that it's not, it can be very frustrating.
We call that a cheater diesel in our house.
Yeah.
That's what we got.
Yeah. There are ways to buy carbon credits, ways to buy nitrogen credits, and actually seaweed farming could become more lucrative because of those credits. So you can look into that as well.
Really quickly, you said there's other species, but what are the other pairings you've seen or done?
Potential pairs would be the rockweed and oysters. They share similar habitats. And I've also been studying eelgrass in Casco Bay and the soft-shell clams that grow in the mud flats just above eelgrass meadows. It's pretty tricky. Eelgrass has been disappearing in the Maine region. We've lost 50% of the cover in Casco Bay in the past 10 years for various reasons. Reasons we might want to protect it.
And so last year, the people who did this panel actually recommended other people having gone through this. So you guys can pick someone else. Thank you.